Earlier this year, Apple released the latest MacBook lineup with the M5 series. I placed my order in late March without much hesitation and went straight for the M5 Pro. Here are the exact specs. I upgraded both the memory and storage and chose the highest-end chip configuration with an 18-core CPU and a 20-core GPU. The goal was simple: better AI capability. If you have watched my previous videos, you may know that my main machine is a dual RTX 4090 workstation. So the real question is, can the MacBook M5 Pro actually compete with the experience of using NVIDIA GPUs? In this video, I will talk about that based on my own real-world usage. I will look at 4 areas that are closely related to AI workload. First, let's look at memory capacity and bandwidth. For the dual 4090 setup, I compiled and ran NVIDIA's official CUDA tools for the M5 Pro. We can simply check Apple's official specs for this exact model. The raw screenshots here are a bit messy, so just look at the summary table in the bottom right. In terms of memory capacity and bandwidth, the M5 Pro clearly beats the dual 4090 setup. The Mac uses unified memory, while the RTX 4090 does not support NVLink, so the difference is quite obvious. Next, let's test local LLM inference performance. Unless you're dealing with very complex tasks, running an efficient large language model locally can be a strong option for both privacy and cost for this test. I chose low-bit quantized versions of 4 models: Google's Gemma 412B and 31B, and Alibaba's Qwen 3.527B and 122B810B. What you are seeing now is the real benchmark data measured with llama.cpp. The dual 4090 results are on the left, and the M5 Pro results are on the right. I converted the raw results into 3 metrics that matter most in real-world usage. First, TTFT, the waiting time before the model starts generating the first token after a prompt is sent. Second, OTPS, the output generation speed. And third, MCL, the maximum context length the model can practically hold. As you can see in both response latency and inference speed, the dual 4090 setup has a clear advantage on average. Its output speed is around 3 times faster. When it comes to the context length that can fit into memory, the MacBook does have an advantage, but only by around 15%. Even though it has 33% more total memory, that memory is unified memory, and normal daily use already takes up at least 10 gigabytes. So, the context advantage is not as large as it may seem on paper. For 100 billion parameter class models, both machines can only handle the 3-bit quantized versions. Besides large language models, AI image generation is also a very useful workload. For this test, I chose Flux One Dev, one of the most popular models right now. As you can see, the image quality from the 2 machines is almost identical. Since the biggest challenge in local AI GC is high-resolution generation, I tested both generation speed and maximum resolution without falling back to the CPU. On Linux, I used transformers plus accelerate. On Mac OS, I used VipFlux for inference. After plotting the table as curves, the difference becomes very clear. In generation speed, the dual 4090 setup is almost 10 times faster. However, in maximum generation resolution, it falls far behind the M5 Pro. As a side note, in real-world use, if high-resolution generation fails because of out-of-memory errors, you can enable CPU offload to finish the generation at the cost of speed. Finally, let's look at training. I think this part is especially worth exploring, because Linux with NVIDIA GPUs can use the mainstream PyTorch, CUDA, and Qdin stack. The MacBook mainly relies on the MLX community, so the ecosystem is still more limited. I prepared around 20,000 cooking-related training samples and used them to fine-tune Qwen 3.54B. The table shows several key metrics. Personally, I think the second column, training speed, is the most important one. The dual 4090 setup can reach about 4 training steps per second, almost 7 times faster than the M5 Pro. For me, that alone makes the result quite clear. Overall, my conclusion is this. If you are a heavy AI user who cares about efficiency, a Dell 4090 Linux server is still the better choice. Whether we are talking about training speed, inference speed, or ecosystem compatibility, it is the stronger platform. If your main use case is AI GC style rendering workflows, then a MacBook with a large amount of unified memory has a slight advantage. And if you also care about portability, silence, and a comfortable working environment, then the MacBook's advantages become even more obvious. From a cost perspective, the laptop also uses much less electricity. From my own perspective, after 3 months of real-world use, this MacBook has been fully capable of local LLM deployment and general algorithm training experiments. Most importantly, its portability fits my workflow very well. At least for me, I do not regret buying this MacBook M5 Pro. That is everything for this video. I hope this gives you a useful reference.